Hello everyone, my name is Nathan and today it's time for another episode of Oxygen Not Included here in the One Duplicant Challenge. In the previous episode we started a wild mushroom farm in order to feed the resin tree, and I've actually made a little bit of progress here in terms of planting, so it does continue, even if ever so slightly. It has been suggested to improve the fish tank. We will probably do that. The problem at the moment is to improve it, I will have a need of a constant supply of new seeds. So I will have to take care of that first. Right now we are growing everything in the wild and therefore we do not get any additional seeds. This actually brings me a little bit sooner than intended to the topic of mutating plants. In order to mutate plants, we're gonna need lots and lots of radiation. If we just check out a farm tile here with a mealwood seed, it can go up to 4,600 rats per cycle. And I think that is just ambient radiation. If we check out uranium doors or something like that, even 2 only give us 86 rats. And here, exposed to space, we only get 125 rats. So I figured what we first need before we can mutate plants is a steady source of radiation. And in order to do so, we're gonna build a starter nuclear reactor. I want to keep the nuclear reactor area kind of out of the way, and it is not supposed to feed our power system. It will feed our power system, but it is not meant to do that. What it is meant to do is just produce an awful lot of nuclear waste in order for us to have an unlimited supply of radiation. So what I'm gonna do is continue the ladder here all the way to the top. Let's actually see. I'm gonna need some insulation material. Well, actually we need the space for some steam turbines. So maybe we don't go all the way to the top so we have a little bit of space to work with. So what I would like to see is the edge right here, and then maybe we also continue building the nice border over on the other side. And actually looking at this, maybe I want to build the ladder somewhere else, or we just keep this as a ladder shaft to go up. That might actually be the better solution. I think to get a nuclear reactor going, we want at least 6 steam turbines. 4, 5, 6, but maybe just to be on the safe side, I'm gonna go with 8. So we're gonna build all of this shebang over, and this is gonna be the width of our nuclear reactor. Now, heading into radiation, somewhere in the center here, we want our nuclear reactor, and it's actually a 5-wide building, so I might want to move the steam engines on the right side just a little bit to make space for symmetry. Or wait, even better, we can just go with 7 engines instead of 8. This way I can have the nuclear reactor beneath the center turbine. I'm gonna build the reactor on mesh tiles, and just to show off, we're gonna build them out of niobium. Next, I'm gonna set up a little pool for the nuclear waste to be collected from the research reactor. So it will just drop down here and we can start collecting it using a liquid pump. Have that pump right here together with a hydro sensor and of course connected with some automation wire. I'm also gonna set up a signal switch and some automation wire so we can shut this down, and just to be sure I'm gonna build it out of steel. Then maybe another thing we're also gonna need is a pressure plate. Let's go with a weight plate here. And I'm gonna put that right here in order to have some control over how much enriched uranium I'm gonna feed to the reactor per cycle. We then also need an auto sweeper that I'm gonna place somewhere here, and it's gonna feed that uranium directly into the reactor. I'm also gonna grab a conveyor chute, maybe place that right on top of here. We'll add a conveyor rail going all the way over to somewhere here where we're gonna input the enriched uranium. To regulate this, I might want to add a conveyor meter right there. So the stuff is first going through here and then directly to the chute. We then have to go ahead and provide some power to the whole shebang. We have so much copper. I think I'm just gonna go for that. We also lead this down to the pump and then somewhere along these lines to the outside world. As a matter of fact, we can already set this up going through all the steam turbines, and then we would also be going the ladder shaft all the way down to the bottom where we can meet up with our current cable. This would already mark the bottom side of our nuclear reactor chamber, and we don't necessarily have to make it this big. Actually, this part here got smaller. Now, if I'm not mistaken, the update changed something about the drywalls. First of all, they are now in the base category, and they don't take as many materials. So only a quarter of the materials are necessary, which is absolutely amazing because we need to fill this all out with drywall. Blobbly blob blob blob. Yeah, there's quite a bit of work to be done on this build. And of course we kind of have to build more ladders in order to be able to reach all the spots, and maybe we build the nuclear reactor later on when we got the structure finished. Now, Nathan, all depends on you. Did you just get yourself trapped? No. Okay, wonderful. This is totally gonna be worth it. Once we get everything rolling, we can play around with radiation and mutation, something I haven't done a lot. Of course, that is provided everything goes right, because there is a slight possibility that everything goes wrong. Okay, I think we're making good progress here. As usual, I brought with me a bunch of chests so I can ship large quantities of building materials to the building site and be a little bit quicker about it. Like, I'm bringing some more refined copper right now, setting this to priority 4, I'm then gonna start building again. And this way I waste much less time on traveling. And I'm already setting up some drywall behind the steam turbines, and of course we're gonna fill this up with some supercoolant. That actually reminds me, we're gonna need an aqua tuner in order to keep that supercoolant cool. And I think I might just have it all the way over here, of course made out of steel. And then let's hop into plumbing. We need a thermosensor. We're gonna go right here together with some automation wire. We'll add our usual cooling loop here with the bypass and everything. And then we might just wanna go ahead, lead this all the way up. Use some radiant piping in order to keep the steam turbines cool. Actually, let's first go over so we don't have to use a bridge to accomplish this. And then at the very end, we go all the way back down into the loop. And maybe just to be on the safe side, we hop over this and will not have unnecessary heat exchange between the plate and the pipe. Now, to make this loop stabilize, I think what I want to do is set up a liquid reservoir here somewhere on the side. Maybe I'm just gonna do it straight up right there. Yeah, I think that's gonna be fine. It needs to stand on something though. Let me get another load of copper, and then maybe aluminium would be great as well. So as soon as I'm doing this errand, which I should be doing right now, very good, I'm gonna switch this to aluminium. So now we have a delivery of copper. I'm gonna deselect the copper and I will be going for aluminium next. As for the other guy, it would also be great to get some more obsidian, to be honest. Now, I should have some aluminium here, not too much. Let's do another load. Let me see. Yeah, it's current errand. Now, aluminium is priority 4, and we have this other storage bin filling up with obsidian, and we're gonna switch that to, let me see, igneous rock. Yes, we need some igneous rock as well. Actually, igneous rock is really close, so we don't really need to do that. Let's just go ahead and continue the building process. And then before I forget, we want to cut this up, make the pipe first go into the reservoir, and then it's gonna go from the reservoir into the loop into the aqua tuner directly. I'm also gonna exchange these two tiles here with insulated tiles. And yeah, I guess now we're just going on a building spree. This is actually going rather quickly, considering we only have one duplicant. The secret is really to first bring the materials over and not lose that much commute time. Very nice, we're almost done with the build, and I also realized that our first dust caps actually grew. Right now they are set to not be harvested by my duplicant, which is fine. All the dust caps on the top have been planted, so just the bottom ones are left to go here. Something else that I built here is a quick construction in order to implement the supercoolant here into the liquid reservoir. I think just bottling up some supercoolant here is gonna be much easier, instead of building a pipe all the way from the source. I also already built the piping here for the steam turbines. Now the nuclear reactor is creating some steam, so we don't have to put the steam back into the chamber. We can just dump it if we want to. Here is our first supercoolant, and it should be going into the liquid reservoir and then into the cooling loop. Now, before we do something wrong, let's set this to an impossible setting. And so it is just gonna bypass the aqua tuner for now. For the time being, I think I want to cut the output of the reservoir so we can fill it up with a good amount before setting up the final loop. The wayplate right here, I think I'm gonna set to below 10 kilograms. So it's gonna send a green signal if we are below the 10 kilograms. And right here, I want to limit this to just 1 kilogram. So it's gonna allow 1 kilogram of enriched uranium through as long as we have a green signal. And there is our nuclear reactor. Now, one thing we're definitely gonna need is a constant supply of water. So it's time to pipe this all the way over to the left. Yeah, we need water all the way over here. Wow, this is a huge pipe, but we need to be able to feed the reactor. So I'm gonna lead the pipe straight in there. Now, over time, we actually might run into issues here. What if we don't use the nuclear reactor, but it is still quite hot? Then the water inside of these pipes is eventually gonna evaporate. So I think what I might want to do is just build a bunch of insulation. We should be able to do it. No, we don't have the necessary isoresin for that yet. I'm gonna be using a bridge right here, which is okay because we'll have a vacuum. But otherwise we would have to be careful here because this is transferring the heat. But this is gonna allow me to set up another bridge right here and then connect these pipes so the water can actually flow in. Now, what if we just made a bypass? Yeah, we could add a little bypass right here together with a liquid shutoff. Gonna place you right here and then we can detect the heat. Let's do that. The idea is I basically let this run in a loop and then we use a bridge so new water doesn't have the priority and the old water will be used up first. That means if my nuclear reactor is ever offline but we still have heat going on and the water is heating up, it will be looping in this fashion and we can then simply detect right here with a pipe thermosensor if the water is too hot. When it is too hot, we will open up the shutoff and expel the liquid somewhere. Now I need to be careful because somewhere here I would like to route my nuclear waste pipe. And that means if I want to dump the hot water, we best bring it up to the steam turbine pipe, which is also liquid that we are dumping. So I gotta be careful to set up bridges where necessary. So now this pipe goes up into the dumping pipe. Yeah, I think that is a good solution. If I had insulated pipes or enough materials to make them, I would have done that. Now there's one more thing I would like to build, and that is a collection area for our nuclear waste. Let me think. We first need to introduce the water. We're gonna do the same trick as we do with our other liquid compression systems. So I'm gonna be adding something along these lines. Maybe we first do the outside. Yeah, that might be wise. And with a little bit more than 2000 kilograms, I'm pretty happy here with the supercoolant. So we're gonna disable these, let the pump the rest up, and then we can deconstruct it again. Deconstruct these helper pipes and we'll be able to reconnect this. So now we can re-add the last steam turbine, and if we check the output, they are all going over here. There's just a chute missing, liquid vent, iron, right there. I brought a whole bunch of igneous rock over. That is mostly what we still need to finish the build. Wonderful. I am back with the hopefully completed build. I realized, while introducing the water, that the loop didn't work. So now the way we're doing it is we are still bypassing it right there. And whenever this pipe heats up too much, then it is gonna go through the shutoff. I had this pipe connected, but I disconnected it again. So it's still gonna have the same functionality, but the loop is not gonna be in constant motion. Another thing that I added is an atmo sensor here together with a liquid vent with the incoming water pipe, and the reason for that is we might have too many steam turbines, so they might suck out too much of the steam, and if that is the case, we can, as an emergency, add more water this way. The problem is the ambient temperature here can only be set to 20 kilograms, and I much rather have 100 kilograms or so in here, but I guess maybe 20 kilograms is also gonna suffice. We'll have to see. Other than that, the room is closed off. I added a conveyor loader here that we're gonna fill up with enriched uranium. And before I do anything that I'm regretting, I'm gonna cut this off. Let me see. Yeah, we already have the power. I also added a power transformer so I can add the power for the liquid pump. And we have a hydro sensor right here so we can have the 2 layers here filled up with nuclear waste. It's gonna be a little bit of a waste. But then again, we could go ahead and at the bottom add something to collect the radiation. But with that out of the way, I think it's time to test things out. Let's set up all the sensors here. I would like to collect a substantial amount of nuclear waste here. Let's say we only allow ourselves to pump if we are above 200 kilograms. The atmo sensor here should be set to below, but we first need some steam. I don't want a whole bunch of water here without a real purpose. Actually, that is a lie. We need to introduce at least a little bit of water here so we can already run the thermal aqua tuner, and then maybe we can already decide if we need more water. Let's set up the aqua tuner thermo sensor. This can be fairly low, but I'm gonna set it to about 50 degrees. So above 50 degrees, we wanna cool things down. Also right here, we're gonna be needing a little bit of supercoolant. Let's make sure this is being delivered. Maybe 2 bottles are gonna be enough to cover this up. I do have the drywall behind the steam turbines finished. There's my supercoolant, and oh my gosh, I don't have it finished. Yeah, we're missing a piece of drywall here. Okay, that's my bad. With that out of the way, we should go ahead and connect this up. The power transformer now has the power and it will be cooled down by the water. My second bottle of supercoolant is incoming. I'm gonna disable it. And now we already have around 300 kilograms of water here at the bottom. This should be enough to get ourselves started. So I would say without any further ado, we can get the first test launched, right? Let's maybe do a save game. The main reason I want to do a save game is not because of the failure, but because I'm not 100% sure if the conveyor meter is going to do what I want it to do. Let's get this hooked up and see how it actually behaves. At the moment, we do have a green signal, of course, and it's going to the reset amount. Now, what I would like to see is only 1 kilogram actually going through the meter at all times, and that is actually looking good. So now we add 1 kilogram at a time until we get to 10 kilograms, and we actually end up with 12 kilograms. That is because we have like a pipe or two before the signal arrives at the conveyor meter. This essentially means we want to set this to 8 kilograms instead of 10. So we get the 2 additional ones and then we have 10 kilograms, which means it's going to last for a cycle. Now the problem about this is if we lose a little bit of weight, then of course new enriched uranium is incoming, and that means there's always going to be 10 kilograms on this tile, and that means the auto sweeper is just going to keep on going. So I did not do a good job here. Oh, I also totally forgot to set up this sensor here. If the water gets really close to overheating, then we want to send green signals. So if we reach 90 or so degrees with our water temperature, then we want to open up the shutoff. I think we might be able to fix that by adding a timer sensor here as well, and then just let it go through an AND gate. So maybe let's do the AND gate first. Gonna have that right here. Yeah, that makes sense. Cut this line and then make it go down below instead. And this would then lead to my second sensor, which is a timer sensor. Where did you go? Right there. That means we temporarily have to make our way back inside the contraption, no problemo. So now what we're gonna do is basically activate the timer sensor for 8 seconds every cycle. So if I put this all the way up, then we have 600 seconds time to use up the 10 kilograms of uranium we initially have. And then the weight plate is just going to make sure there is exactly 10 kilograms and nothing goes wrong with the signal. Because if you send a green signal for just too long, it's going to send 2 packets either way. With that out of the way, let's get this going. We are introducing the first enriched uranium. We have some water in there, 12 kilograms of enriched uranium, and already quite a bit of nuclear waste. So you can see this is a good production here. Now, of course, the radiation is going to go through the roof. And I mean literally through the roof. But you can already see how this is going to be beneficial in order to mutate a couple of plants. Let's see, at some point the water should be used up here. Is this heating up in any way? No, not at the moment. What are you doing? Yeah, there we go. Okay, we got the steam. Well, holy cow, that actually took a while. And now we also get our initial nuclear waste here in the joint. That is good. This is already going for it. And now we are just waiting for all of these to activate. Yeah, we just need to wait for a bunch of water dump cycles. And this seems to go on. Now, one flaw of this contraption is still that we are basically wasting 3 packets, but it's just water. We have an infinite amount of it. Eventually this water should then also heat up, and hopefully, if we are lucky enough, we can keep everything cool until we have it filled up with enough steam. This is looking very good so far. It's still quite cold, to be honest with you. And more nuclear waste. Oh yes, I love it. I love it. This is going to be an extremely dangerous zone once we have this all compressed with nuclear waste. Oh yeah, I really like where this is going. So far everything is working out. We still have around 4 kilograms of uranium in there. Let me see, I might not want to reset that too early. No, it's actually not bad. If we get a little bit of extra, we can observe how this is exactly working. Where's my timer sensor? So now we are getting these 8 seconds. And was that enough? Let me see. Yeah, we did get the 10 kilograms, or at least almost. I might have to add 1 more second to the green duration. Maybe there's a little bit of animation delay. Oh, I totally missed it, but we already started to pump things out. Oh, I see. The viscosity here is a little bit higher. So we keep on pumping, even though, yeah, we need to add more to this. Let's do 500 kilograms. But essentially, it is now dropping right here. We're going to be filling up 2 rows. And once that is done, we just need to add a drop of supercoolant or petroleum. Actually, supercoolant might be lighter. I do know that petroleum should stick above it, but maybe we can try supercoolant. Great stuff. We're now collecting nuclear fuel, and of course we are also adding to our power. Right now, not by a lot, but once we get this water to heat up a little bit, we should be fine. With that out of the way, thank you so much for watching, guys. I really hope you enjoyed today's episode. Have a great time, and hopefully I'm going to catch you in the next one. Bye bye.